All right, in this video, we're going to look at ES3, the Earth Science unit for 8th grade. How are the Earth changing? And this is your classic earthquake, volcano, plate tectonics unit where you're just looking at that. But iQuest does it in a different way where they really want students to generate their own ideas and their own thinking around that. So you're not just telling them, but the students are actually experiencing it. Now, the anchoring phenomenon that they have for this one that they talk about is to just look at the maps of earthquakes and volcanoes in the world and start asking questions, which is fine, but it's not that great. And since we're in the Pacific Northwest, it makes way more sense to talk about the big one that's supposed to hit the Pacific Northwest. And that being the anchoring phenomenon, very real, very true. We don't know when it's going to happen, but the point is that students should learn about this because we live in a volcanic zone and also in an earthquake zone. And so there are a couple news or a couple videos that you can show to students that will help to illustrate that. So that's that. But generally speaking, the unit goals here are to really highlight what is going on in the earth and what is happening, how is it changing, and how do plate tectonics play into this idea of volcanoes and earthquakes. So learning set one, in learning set one right here, we are going to really focus on the evidence for the theory of plate tectonics. So all of it kind of builds from the beginning as to how do we know the theory of plate tectonics is even a thing? And I don't even talk about that. Students may bring it up, but I don't talk about the theory of plate tectonics until we get later in learning set one. So you start off the activity with those anchoring phenomena that the unit talks about, which is just to look at maps of the Earth. There are some maps that come with iQuest. I prefer to use Google Earth. Google Earth. And the problem that I have been having, I was looking for it and I couldn't find the data sets that I like that show all the earthquakes from the last 50 years or 100 years or something like that. And it just shows all these earthquakes. And I couldn't find it. So I'm a little bummed about that. You can get maps of it. Students can actually zoom in a little bit better. So computer, I think, is still better. I'll work on finding those maps they're going to work out. But Google Earth is cool because you can really zoom in and really take a look at things. So your driving question board will be focused on the map that came with the unit. And on that map, as you go through it, you'll draw things on there so students can see it all in one place. And so you start with the pattern of volcanoes. So students look at the volcanoes around the world and they see that the volcanoes are generally speaking in lines and only show up in certain areas. They are not spread out evenly around the world. There definitely seems to be a pattern, and they generally are found along coastlines as well. So the vast majority of them are found along coastlines. Also fascinating. After you do volcanoes and you go to earthquakes and you look at the map, and that really shows how the earth is stitched together, or it looks like it's stitched together like a baseball with earthquakes. And so there's just tons of them, but they're all in these really defined lines around the earth. There's a few randoms out there, but for the most part, the earthquakes really fall along these lines. We know that it is because that's where the plate boundaries are on the tectonic plates. But this is something for students to discover, not to talk about yet. So you let them collect this data, ask questions, make predictions. Somebody will throw in plate tectonics. Is that where the plates are? That kind of thing. And then you just ask questions like, oh, what do you mean by plates? What have you heard about plates? And say more. And if they can, then great, that's fine. But if they can't, that's fine too. We're just trying to get them to start talking about it. And then the last one in lesson one is to look at the world elevation. And again, I really like doing this on Google Earth because the elevation and the water and everything really shows up well. And you can see how it looks like where there's cracks or some sort of feature in the ocean, then you're also going to see volcanoes and earthquakes or earthquakes. So really, really ties that nicely together. So let students know there are physical manifestations of something going on, and that's where these earthquakes and volcanoes are showing up. And so that's lesson one. Lesson two, then you start off by bringing up this whole concept of South America and Africa and how boy, those two look like they just fit like a puzzle piece in here, right? I mean, don't they? Come on. And so, but then we talk about like how would that even work? How could you get these things to move together? And what is there any other evidence that shows that these two continents were once together? And so they do this little jigsaw activity. 2.1 is a jigsaw activity where you get students, some groups will get the jigsaw idea, the fact that the plates fit together, looks like they fit together. Others will get fossil records, either showing that there are fossils that are the same on both sides of the Atlantic Ocean. So there's a prehistoric animal that lived in both places. So the fossils are found in both places. That's kind of unique. And rock deposits, rock sequences, all kinds of different things. Climate change in Antarctica. So Antarctica has fossils of tropical plants in it. So it's like probably wasn't in the same place it is now. So they do that. And then 2.2, you dig into more evidence on the seafloor where you look at that ridge that goes down the center of the Atlantic Ocean. And that parallels the coast of Africa. And so it really shows prominently that there's something going on there. And they'll also see there's volcanoes there, there's earthquakes forming there, so something's going on. They'll look at these trenches, what's going on with the trenches, and then you have volcanoes near these trenches. And then the clincher for most people is the age of the seafloor. And so when you look at and this image is kind of hard to see, I don't know if I can zoom in on it or not, but if you look at the middle of the Atlantic Ocean, the darkest red is the youngest rock and the blue is the oldest rock. And so you can see it parallels on both sides of this. So it shows that these plates are spreading apart. And so South America and Africa are spreading apart. And so things are similarly going on in the Pacific Ocean, but it looks different. It's not this beautiful parallel line. Okay, it's not parallel, but really matching up on both sides, right? So the age of the rock really matches up. So I'll go to that. And then we get down to 3.1 and the theory of plate tectonics. Now they have them do this modeling activity, and I don't personally like the modeling activity. I think it's kind of a weird activity. Maybe I just haven't figured it out. Maybe Jessica Johnson has a better way to run it, but I never liked it very much. So I have them kind of do not really a CER, but kind of a model that shows evidence of why we think the theory of plate tectonics is real and why I think it's actually going on. And I will tell you this, you could get bogged down in this, especially when you get to 2 and lesson 2, you can really slow down and go too slow. I keep it moving. It's not essential that they master this concept, but just that they have the data and the evidence so they can come back to it and use it in 3. Because really it's 3 where they're trying to prove that the theory of plate tectonics is true. So you can do a CER for this, is what I have often done. CER or a model. I've flip-flopped between the two on that. So that's learning set 1. So the Earth is moving. The continents are moving around. That's what we learned in learning set 1. Learning set 2, now it's kind of getting into that cause. Like, why is it doing that? What could be going on? So we're getting into convection cells in the mantle. This is all stuff that's really hard and basically impossible to prove, but there's a lot of evidence out there. We're just going to look at a few pieces. There's this cool thing with the tank where you have a glass of hot water down here. You put red food coloring and blue food coloring here, and it really shows a nice convection cell. This should be, actually you do a couple different things. This one is just showing how the cold tends to stay at the bottom, the hot tends to flow up and stay at the top. But you can create this kind of convection current if you have a hot spot here, and that creates this movement. So that's theoretically what is causing the magma to move. But a really nice connection here to the weather unit they did in 7th grade, because you do talk about convection currents in the atmosphere as well. So this is happening in lava, or in the mantle, I should say, and also happening up in the atmosphere. Silly putty rock. It's kind of fun. It basically just shows how as you heat something up, it becomes more malleable, and this is what goes on with rocks. It's kind of a stretch to talk about cause and effect for metamorphic rock. It's not necessary. You could skip it. I don't think it's actually it doesn't lead to the storyline very well, so I wouldn't worry about too much. But if you want another hands-on activity, it's something to do. Lesson 5, then you start doing some of these activities about earthquakes. So when you rub graham crackers together, you see the jello shake. This is a lab that is not that necessary, but students enjoy it because there's food involved. I do let them eat things. Personally, I do. I just make sure they have paper towels and they've cleaned their hand, washed their hands and all that kind of stuff. But that's what's going on there. It's pretty simplistic, you rub it. But I have used, like, students get confused, like, what do you mean? What's an earthquake again? I'm like, remember the graham crackers and we like rubbed them against each other and the jello shook? And they're like, yeah, I'm like, oh, that's a earthquake. So it's a little bit more modeling for them. The spiral notebook and a towel. This just shows subduction, how the continental plate is much thicker, the oceanic plate is much thinner. So the oceanic plate tends to go underneath the continental plate, more dense, less dense, things like that. So you can bring in the concept of density as well. So really in 5, you're talking about subduction zones, getting that going. Let's see, get to lesson 6. We do a little model eruption. This is kind of a cool deal. You have a layer of wax at the bottom, layer of sand on top of that, bunch of water. You heat it up and you do get these little eruptions. Some of them are better than others. Sometimes they just kind of all lump up at one time, but most of them come out pretty good. That's a pretty cool deal. Let's see, talk about hotspots a little bit. What's going on in hotspots, so Hawaii and how that works. And that's kind of the end. So we're just talking about how do you make new rock and how are things moving through the planet? What are some of those movement pieces that are going on? Which then kind of, so like, what are some of the plate interactions, I should say? And then you get into lesson 7, how are the plates moving? And this one, there's some really good stuff from Shake Alert. And there's some good lessons that they have that can model some of the work, because they have done put some seismic meters in California and Oregon, and you can really watch the plate or see the plates move and get a lot of detail and a lot of data for that. But there's some cool activities they came up with that I can share that are pretty fun to do with that, or look like they'd be pretty fun. So yeah, basically determining plate movement. How do we know the plates are moving? Well, we can actually see it now, right? We have GPS data that shows that the plates are moving, in fact, and we can measure that and record that. 8, how do you get new material? This is really talking about spreading zones and the rock cycle. So you have areas where the plates are pulling apart. That's where new rock is coming in. Then you have areas that the rock is going down deep into the earth, and that's a subduction zone. So there's this cycling of rock that happens as well. That's kind of what we talk about in 8. And then the final one, learning set 4, how does plate tectonics explain the features of the earth? Then you're really getting into this large-scale modeling of what does a subduction zone look like, what do transform faults look like. This image is a classic image. It shows all of them. Here's a spreading zone. I guess there's a spreading zone there. Subduction zone, all those things. And so you're trying to get the students to kind of get a big picture in their head of what's going on. I do something with Milky Way bars. Edible tectonics is what I call it, where you can kind of model that again. You spread apart create a little fault in the middle of the Milky Way, pull it apart, and that's a spreading zone. You can see the magma, which is the mantle material, or the caramel in there, and push them together, and you can see the chunks of chocolate like subducting and doing all kinds of stuff. So it's kind of a fun activity. And again, they get to eat, so they like it. So talking about some plates again, building models. A lot of people use that for their final assessment or the case study sites. But I like the idea of really focusing in on the Pacific Northwest and what is your emergency plan? Like, why do we think there's going to be an earthquake here? And what's your emergency plan if you should have, if there should be an earthquake? How are you going to get water? How are you going to get all that other stuff? So that's in brief, in 15 minutes. That's the ES3, how the Earth is changing. And yeah, let me know if you have questions. Cheers.